Good morning, everybody. How are you doing? My name's Shane. Really nice to meet you all. I'll get started in just a moment here. I think we're just shy of how many people we're expecting, so I'll give a few minutes for that. But in the meantime, you can just get used to the setup here. We're going to be doing Python today. Super excited to share some of my passion for my favorite programming language with you all. So where's everyone dialing in from today? I'm in Halifax, Nova Scotia. Nice. Yeah, we had a cold snap within the last week. It dropped down to like -15 or so, and all winter it's been about -1, so it was quite shocking. But back up to around 2 degrees today, I think. Pretty happy about that. Always gets cold here, no doubt. I grew up in Calgary, so I've almost forgotten what it's like to have -30 every winter. Just a few more minutes here and I'll get it started. I remember during first year university, also in Halifax at Dal. I'll reintroduce myself for people that are just joining in a second, but we had such a big snowfall in the first year that we were unable to leave our residence. Like 4 of us were all pushing on the door and slowly opening it inch by inch because it was full of snow. So we're like, we need to get to the meal hall. We're so hungry. But builds character. All right, the class is filling up now. I'm going to get started in 1 minute at 9:05. I just got a little presentation to start just to introduce Python and some of what we'll be doing today. All right, it is 9:05, which means I'm going to get this thing started. So hello again, everybody. Good morning, wherever you are. I hope you're having an awesome day so far, because I sure am. My name is Shane Mitrovitz. I use the pronouns he and him. I work as a program assistant at Supernova on the computer science team. And just a little background as well. I mentioned before I went to university, I did go to Dalhousie in Halifax for computer science. So I am a computer scientist. I love to work on computers, to see other people's amazing inventions in code and to share some of what I find really awesome about code as well. Yeah, I saw a hand up. Or is that just testing out things? If you have any questions at any time, please do drop them in the chat. I will have that on my side view. So I will, am I in a basement? I'm actually not. This is just a room with no windows. So what's the difference? I'm definitely above ground. It's just sort of a nice office space where I can be, just in the zone. So that's perfect. So just to get us started here, I also wanted to, mention that Dalhousie is a company that does STEM. Many of you have probably, seen our things before, but for those that haven't, STEM is like science, technology, engineering, and math. Really everything to do with that field. We love to deliver that kind of content. And so do keep an eye out for our summer camps and other exciting offerings. So I'm going to share a presentation here just to introduce Python, and we're going to be making Tic-Tac-Toe today, which is really, really fun. Well, I mean, it's fun. It's a fun game. I think it's a great place to start in coding, just because we can understand the rules in a way where, we can wrap our heads around it. It's kind of a slippery slope to jump into the deep end and try and make a game, like chess or something crazy. It's really nice to start in a way where we kind of all are aware of the rules. You get 3 in a row, you win the game. If the game ends and there's no one has 3 in a row, it's a draw, right? So we can understand how the game can end, and we know what goes into it. So on the left here, it might be a little laggy with the screen share, but this is a GIF. It's just showing the gameplay. We have a game board kind of displaying each time the player or computer makes a move. So we're going to make a random AI that will make a random decision to play against us. But then in the future, maybe you could add a more intelligent agent that would probably just always go for a draw. I think playing perfectly, there'll always be a draw in Tic-Tac-Toe. But we can definitely win against this random AI. It's going to make bad moves sometimes, and we're going to punish it really good. So we also have the choices by number showing on the bottom here. This is how we're going to accept input into our problem or into our program, so that we need to be able to have a way to choose moves that isn't using the mouse button, since this is going to be a text-based program. Okay, so yeah, that's sort of some of the gameplay. Let's just kind of touch on a few concepts here for anybody that is totally new to Python, totally new to programming. I'm so happy you joined us today, because we're gonna have a lot of fun. So let's just talk about the word programming. People throw it around, talk about it like it's an intimidating thing, but really programming is for everybody, and we can break it down into sections that I trust we can all understand. So programming is just instructions. If I say do something, I'm giving an instruction, and that's all we're going to do today. We're going to use Python to give instructions to our computer that will result in it printing out this game board and an interactive program. Interactive meaning it takes input and asks for input, that kind of thing. So Python is just one language. It's one way to do all of this. So when we want to make something in programming, we always need to think, what kinds of problems do we need to solve? We will look maybe at the different kinds of sub problems that go into making the full game. So we'll need to print out the game board, right? That one's pretty obvious. We need to see what's going on. We need to get player input. We need to figure out what the player is choosing to do. And so if I were to, enter in like something that isn't allowed, right? Maybe just an empty space or an asterisk, something that isn't a number. We need a way to catch that, because if we don't do something called error checking, we can enter a funny input and might even break our program, which isn't very good. We need to update this game board, right? We need to refresh it and show what we're entering and print out the new stuff. And we also need to figure out how we're winning how we decide if the game is won. And I'll just say this right away. There are a lot of different ways that you can check to see if the game is won. The way I did it is just one way. And so keep that in mind. Everything you see today, if you were to just forget about it and then sit down at your own computer and try to make your own version of Tic-Tac-Toe, it would work just as well as mine, but it might look completely different. And that's part of the beauty of code, is that there's a lot of different ways to do the same thing. All right, so just before we get into our code editor or anything, I just wanted to go over a few different aspects of code. So this one is really important. We call it methods, and that's just a special word for a reusable tool to do a job. So when I'm talking about methods, I'm talking about like a tool on my tool belt. One of the tools we're going to use today is the display board tool. So anytime I write display board or like call this method, it will display the entire game board. And so we're going to step by step decide how that game board will display. And then whenever we need that tool, we can call it back and use that when we need it. Okay, so this is just a real example from the method we're going to use today. You'll notice also on the right, we have these comma separated values here. Values, choices, and print choices. These are called parameters, and that's just programming speak for inputs to our method that are used to make decisions. So like within this method, we're going to say, oh, based on this, maybe do that. And we can't base anything on anything unless we give that information to our method. And this is the way we give information to the tool. And again, if you have any questions at any time, like I know I'm kind of just diving into it, showing you some of the way that Python actually looks, giving you real examples of these things. If you see something you don't recognize or you want me to go back to a slide, do let me know. I'm very open to feedback in that way. So we'll also need to do something called formatting. And this is a good example in the bottom left to show sort of how formatting will work today. And this is a standard that is really popular in Python programming, which is why I've chosen to use this. This will be really helpful if you ever need to format what you're printing. So here I'm printing in brackets, just squiggly brackets. And you can see they print out normally. But then we use this thing called dot format. And then in round brackets, we can enter a value like hi. So what's happening here is that these squiggly brackets are actually being replaced. They're being deleted and replaced by this string here. And that's being printed below. So what happens if we enter a variable, and a variable is just a name tag. I always have an issue sort of with the word variable when introducing coding because it has baggage. You know, we think of math, we think of boring stuff, but a variable is just a name tag. Like the way my name tag says Shane, right? I'm a variable called Shane, and I have contents inside of me that can be accessed by using my name. And so the same concept applies here. You know, imagine my name was Ver, and then inside of me I had the number 23. So anytime we're talking to our program, we say a variable is just a name tag for a value we may want to use later. And so if I format this string with var, it's going to replace these squiggly brackets with the number 23 and print it out on the bottom left corner. So that's kind of what's going on at the top. This is, again, a real example from the program we're going to use for Tic-Tac-Toe. And so here I have 3 squiggly brackets, right? I'm using more than one. And so inside my format method here, it's going to accept commas as showing many different values. So this is super extensible. We can make as many different sort of plug-in values as we want to our print statement. And that will be really helpful anytime we want to display information without having to jump through extra hoops. You may think that this looks kind of ugly, and maybe it does seem that way at first, but compared to some other options that are available in Python, this is actually pretty crisp. It will be consistent, and there won't need to be extra steps when I am printing things. So I wanted just to kind of give like the brief, skip over a few things that we're going to see today. So the way that we're going to set this up is basically using a template. And a template will be helpful just to save us a little bit of time on the boring stuff. We have an hour and a half today. It's plenty of time to go over this whole Python program and, you know, get questions back, see how things are working, maybe how we could have done things better too. But we're going to start from a template. So if you have your web browser open, definitely go to this link here. And this is my GitHub page. It will for the Tic-Tac-Toe Python project. And you'll see these 2 files here. Okay, this here is a working example. If you just use that, run it, it's going to work. But this template will be a great starting place for today when we go step by step and build it together. So yeah, I see a hand up as well if you want to, anytime, just in the chat, I'm keeping an eye open. So the second link I've provided is onlinegdb.com. This is a website that's really awesome because we can run Python code there. Yep. Do you need to sign in? No, you don't. Both of these sites do not require login. So when you click on, or when you go to this site here, it will automatically just show you. I cropped it out so that it's easier to look at, but it will be just a GitHub page and we'll show you two links. Just open up the template and there'll be a chunk of code there. I can actually show you that now by going here, and this is what will show up when you go to this link here, and then I will, oops, I'm just gonna enter. So this is the first thing you'll see. Again, the second file is just a working copy of the code to compare. But then by opening the template, I've added a few comments. You know, we've touched on a few of those problems from before, just so that we can keep track of what method is doing what. Oh yes, absolutely. Sorry, I think I still need to wait for the coffee to kick in, but I'm going to copy and paste that in chat for you. Sorry about that. You betcha. These are the two websites that we'll use today. Okay. And so I'll give everyone just a moment just to open those two things up. This is what the GDB website will look like. This is like a programming window that will work for tons of different programming languages. And you can change which language you're using in the top right corner. Today we're using Python 3. So I've selected that here and just leaving that as is. But again, I'll give it a minute. Oh, I've got both. Awesome. If there's anyone having trouble accessing the tutorial template on GitHub, as well as the online debugger window for programming, just let me know and I'll get back to you right away. To copy this code over into our editor, there's a little button here that looks like two boxes stacked on top of each other. It says copy raw contents. So I'm going to left click on copy raw contents. It will say copied. And what this means is that I can paste all of the text from this template into the debugger by highlighting delete. You can right click or also use Control V. You can right click and paste. And that's perfect. This is just handy if you wanted to use your keyboard. How do you copy it over? I'm going to do that one more, or just as many times here. So here we have copy raw contents. Can you see the screen? There are two little boxes there stacked on top of each other, and I'm just going to left click on copy raw contents, and it will say copied. So that now once we have that, it's on our clipboard. We've copied it into our system memory. I can go back over to this other website, and then you'll highlight everything. You can delete it, and then right click, paste, or you can use Control V, and that will do the exact same thing. Okay, so I'm just going to start introducing the layout of this program. I've written this quick overview here just to show on the right side all the methods that we're using in this program and how they align to the 4 points that I mentioned in the presentation. So of course we have display board. I thought this would be a very good one just to include in the template because there are a lot of different ways we could draw a game board using print statements. But I thought it would be best to just provide this as a starting place so that we could also focus on some of the flow of the code and doing that problem solving, because you could customize this as much as you like. I have a clear page ready for coding. That's awesome news. If you wanted to copy and paste the tutorial template to your open page, that's great. But you can always just open another GDB editor, and I mean, I'm sure some of you will, consider grabbing the full code and copying that over to a new window and just running it, seeing how it's supposed to work on your own computer. I sort of included both of those files there so that you might choose to do that. Yeah, Nak, I see your hand. Just let me know. Oh, okay, sounds good. So yeah, basically, when we are printing something, we always use like double quotations. So if I'm printing a word and I type in word like that, I'll get an error because Python is expecting us to wrap everything that we're printing in double quotation marks, and you can see it turns green, and that means that we're printing a string. And a string is just a word for anything in natural language, right? It's anything like words that don't have values. It's just it's a word you'll get used to, and it sounds funny at first, but the reason they call it a string is just because we're stringing together lots of different characters all in one sequence. So if I printed word, that would print out in our terminal below word itself. But when you run this, you'll notice nothing really happens. We got a def indentation error. Okay, computer choice. I think there's going to be errors because all of these methods are empty right now, and the program doesn't really like that. So nothing will really happen yet until we give some substance to all of the methods. And the reason for that, like if we added like the word return in each of these, it wouldn't give an error in the same way. I use tabs on my keyboard to format things. Sorry, that was, yeah. Okay, thanks, C. I will definitely slow down. I know that this is definitely it's a lot to look at first, so thanks for your patience there. I will definitely slow it down, and we'll start just in terms of those 4 problems that we had from before, okay? So I'm just going to kind of recap what those 4 problems were. We wanted to print the game board and legal choices, right? So that's sort of what our first method is doing. Let's rewind then, right? So again, we're just focusing on these 4 problems that we're going to do. And all of these other methods I've just left empty so that we can start to solve these problems step by step so that we can start here. So print the game and the board and legal choices will be this chunk here. So to do that, we are going to also need to make these values for values and choices need to have a value before it will make sense to our program. And so we're just going to set up those variables. Very first thing we're going to do is just at the top here, I'm going to type in values equals, we're basically setting up a list here. In Tic-Tac-Toe, there are 9 spots on the board. And so we need 9 different values that our player can update and that the computer can also access too when they play. So to set up an empty list of 9 spaces, we're going to use square brackets, simple quotations, and just use *9. Zoom in a little bit. Yeah, I think this will be nicer for the camera. How is it looking, by the way, in terms of in terms of the visibility on your end. A clear page, Mohammed, you would basically just type in this website, and it should have a few things on the page to start, and you can just delete those things. So yeah, we got another hand. We're just going to go really slow here and try and get through everybody's questions. So if you're feeling, just like I haven't gone over something, I probably have not gone over it in detail enough, but that looks like 2 boxes stacked on top of each other. Yes, so when you follow the GitHub link, you'll see this page at first. And so from there, you'll just open up the tutorial template. And over here, we have this little copy raw contents button, okay? By clicking this, it will copy all of the text in the page. The same thing you could do by just highlighting everything and right-click copy. It's the same idea. So that's what we're doing here is we're copying all of the text and putting it into our text editor over here. So yeah, we're basically just setting up a few different variables right now so that we can access the values on our game. And now we also need to decide on what our options will be. Just one moment, please. So to set up our options, we need to think. We are going to accept input from numbers 1 to 9. And so when I type number 1 on my keyboard, I want the top left spot on the board to display. Basically, we need to start up our choices just to have a list of numbers 1 to 9. Okay? And so when we want to make a list like that, we use something called the range function. This is kind of included in Python, and we can use a range between 2 values to count between 1 and 9. It's going to be 1 less than the second value, and so when we print out this options list, it will just be a bunch of numbers. But we want it to format as a list, so we're also going to wrap this word list around range. And again, right now we're just setting up our lists so that we can manage the input of the users. I heard another question. One moment, please. I have a lot of windows. Yeah, Nak? Oh yeah, so can't copy the tutorial. Okay, so I will let you know. So when you go on this tutorial, are you able to find the copy raw contents, Nak? It's not there. Okay, so if you don't see this, then another option we can do is to basically highlight all the text and then copy it that way using either Control-C or right-click and copy. Let me know if that works for you, okay? Are there any other questions? It's not working for you. Okay, I'm going to slow it right down. Thanks, Declan. And so basically the template is not going to run because it's supposed to be 4 values. So basically all of these here, this is all comments. So this is not part of the code. Anytime we have these 2 hashtags, it makes it so that you can just read what I've written. And so before values, this is like kind of the first thing I'm writing in the program. And this is going to make it so that values is just a list of empty spots like this. I'm just kind of showing what it will actually do. That's what we've done here. We made a list of spaces, and we're going to, is the update tutorial the right one? Yep, the most recent tutorial is the correct one that we're copying over. And so by doing this, again, we're setting up this list of values that will slowly update with X's or O's, okay, as we make choices. And I'm just going to also write out what options are here. This is the value of options since we've added the list here. And these will be the only legal moves that the player or the computer can make. So when I type in like the number 1, I want a certain square on my tic-tac-toe board to be chosen. I'm sorry to hear about that it wasn't working before. Yeah, I'm happy to reshare the link here. Link address. And Onlinegdb as well. Hey, make sure that when you're on Onlinegdb, you go to the very top right corner here and choosing the Python 3 drop-down menu. I just realized that on my screen share, it's not showing the drop-down menu. I think that the website thinks it's not part of the window. So that's one of those things I only can realize on the fly. So I'm just going to highlight this section right now, making sure you select Python 3, okay? Yes, Mac? I will actually change this options to be more of a descriptive name. I was talking about before how variables are like name tags so that we can understand what they are. These are really the choices that we can make. We're making different choices based on these numbers. So I'm just going to call that choices really quick. Okay. And so from there, I'm also going to make the options list. So as we go through things, we want to show basically the difference between the choices we can make and also the options that are remaining. This will help us when we format our board as it prints out. And I'm going to use a method here called copy that's, again, just built into Python. There's a lot of methods that are preloaded in Python that will work for like any list or any string. And this is a method that works for lists. Writing these values in or just watching. Yeah, so basically, if you wanted to see or go along with what I'm doing here to build up to the place where you can see the full version of the project contained within tic-tac-toe.py, that's what we're doing today. I'm just showing you like sort of the process of how you would identify sort of what game you want to build and the steps that you take to make that game. So if you're finding that the way I'm presenting doesn't quite work in terms of you want to like write alongside that, then I'd encourage you just to stay tuned and like see how we build this program. But again, I've provided that full program to test out on a separate occasion. But yeah, I encourage you just to do what's comfortable. There's no right or wrong way to enjoy the session. It's all just about Python and one of the cool things we can do with it. And again, we're working on a game today. There are so many things we can do with Python. Pretty much anything on your computer can be done with Python. You can move a file, you can read a file, move things around, all that stuff. And also a lot of things on the web as well. It's a super robust language. There's tons of things you can do with it. And so by no means does a game represent all that's possible. This is just showing how we would, translate that into a real game. So with that said, we are kind of interested now. We've set up these 3 values here, or 3 lists, I meant to say. And these are the 3 lists that we'll need sort of to keep track of what users are doing with our program. So the next thing we'll need to do is in get player choice, this will be how we're collecting user input, okay? So let's just imagine for a second, I say, hey, you can choose numbers 1 through 9, and then you say, haha, and you hit enter, or you say, -1, and you press enter. I don't want that to break my program, and so we need to think of a way to handle that on the go. So using error checking will be really helpful in a lot of different situations, anytime you want to make your program more predictable. So with that said, we're going to get started on our get player choice method here. So I'm just going to make a little space, and we're going to use a while true loop. Many of you may have used Scratch, many not, but in Scratch this is called a forever loop. And this will make it so that we are doing a series of steps, and then when we get to the end, we just start from the top and we do it all again. And the reason why this doesn't actually go forever is because of a statement called break in Python. And so when we say break, we say break out of the loop and forget it happened. We just keep going. So that's sort of the main idea here, is that we're using this forever loop to always be checking for a user input. And then when we're satisfied and we say, hey, I am muted. I hope other people can hear me. Right on, okay, thanks. Yeah, so while true, we're always checking and trying to get an input. So I'm using another type of conditional statement called try. So we're trying something. We're going to give this process a try, and if something bad happens, then we can react, right? So that's the benefit of a try statement, is that if something goes wrong, we can catch that and do something else instead. So we want to say that the user is making a selection. We're choosing a number. And we're going to say that's equal to input. This is a method that will take in input from the user. So by itself, it's not going to do anything. It's just going to be input by itself, and nothing will happen. So I need to say, your move. Choose, or I'm just going to leave it as this for now. Your move, and I left a little space here because if I don't leave a space, then it will put my answer right beside the exclamation point, and I want it to be a little bit of a space there. Okay, so we're off to a blazing start here. We're getting this player choice. Yeah, I'm sorry about that, Mohammed. I hope that it will push through for you soon. Yes, yeah, I'll absolutely leave the screen as is. So this here is going to basically always be checking and trying to get our input. So the next thing we need to think about is, what if we give an input that is a number? How will it be stored in memory? Well, there are different data types that will allow us to store different kinds of information. So if I had, I'm just going to write like separately here, if I had a word like this would be a string, right? This is a quotation word that has a certain kind of data type. But if I had like the number 23, for example, this is an integer, which is a whole number. So we don't need to like get too into data types today. I'm mainly bringing this up because when we collect input from the user, this will be something that is in the back of our mind. We want to try and predict what kind of input and data type we'll be using. So with that said, I am also going to wrap this input as an int, just like that. So what I've done here is something called casting. By putting the int method around the input method, I'm basically saying whatever I get as input, I'm going to cast it as an integer. So if it is a whole number, then it will work and no error will happen. But if I enter a number like 1.5 or some kind of decimal number, anything like that, it will throw an error. And that error will be caught in something called an except statement. I would normally try that. In the past, when I've done that, it's also sort of created other issues for different students as well. Are there other people experiencing audio troubles right now? Okay. I'm just going to kind of proceed like explaining how we're going to catch this error here. So again, we're imagining that like the user gives a value like 1.23. This isn't an integer. So it's going to basically raise an error that's going to be caught in an except statement. And anytime it doesn't match the casted value, it's going to be received as an integer. Yeah, that's a great idea, actually. So basically, as I go through things, I can make a copy of the key points of that sentence. But it is one of those things where to be talking and saying the exact same thing as you're typing, as well as looking at chat and the screen. I don't know if I'm quite that good at multitasking. I like to think I'm not bad, but you know, I've been wrong before. So the value error, again, is going to be value error responding to ints cast error. Okay, so when a value error happens, we're basically just going to print out what the user needs to know. I'm going to say, please select a whole number. And this is where I'm going to use that formatting thing I talked about. I'm going to use some squiggly brackets here, 2 squigglies. I'm going to do .format options. Okay. So when I do this, what I'm doing is I'm actually printing a whole list into these squiggly brackets. This is part of why format is so powerful and why I've chosen to use this way, is because if I have like an integer that I want to print, or a list that I want to print, or a string that I want to print, these are all different data types, and it can get messy. You need to figure out how to print them all as a string, or format will do it for you. So that's kind of the benefit to using it this way, is that it will look cleaner. Okay, so now we have basically verified that making sure selection is an integer. And now we need to make sure that selection is actually allowed, right? So this is a little bit different. We need to make sure that, this number that we're choosing is inside of that list of numbers that are legal moves. And so to do that, we're going to use something called assert. Assertion means like, hey, I'm claiming this. I'm saying that this must be the case, right? I'm asserting that selection in options. This is the in keyword. This will allow us to say, does this single value exist inside of a list called options? So again, selection is basically the variable we're giving to the user input that was given. And we're saying, okay, this selection that you made needs to be inside of the options list. Now, what happens if it's not? Well, an error for sure, but not exactly the same kind of error as we had before. So I'm going to just type this out. We have except assertion error. So an assertion error will catch this if it is not true. If it is just false, it will raise that error. So again, if I choose like 1001, that's not between 1 and 9. That's an assertion error. So it's going to then print out, please ensure that your input is a number from squiggly brackets here. And again, options. So I'm kind of customizing these a little bit. I said whole number for the value error because that is sort of about integers and whether or not it is a whole number. But then an assertion error is like, is it in the right range? Maybe it is an integer and the first thing was good. Then we're going to say, okay, well, it still needs to just be from inside this list. Okay, so now that we have sort of the try and except block set up, we also need to make some changes to our lists once these values have been collected. So what happens now, right? We need to remove the selection from the options available. So I'm actually just going to like copy these down again. Yeah, I'll let you know. So basically, this goes until 10:30, and I do hope to be through the code until before that point, so we can also have a little bit of question time as well. So, and options is it's basically choices, right? This is choices.copy. Just a way that we can make the same list again. So we're going to say that we're removing, yeah, pretty much. So we're removing the selection from this list. And now we're saying, okay, well, the choices list, we need to make it so that instead of a number being allowed to be chosen again for that section, we're going to make it an empty space instead, so that when we're printing out our game board and the selections menu, it won't give that selection as legal anymore. We're going to remove it from the list. What I'm doing here, when I write selection -1, in lists, the way indexes work is that this is, the first item, this is the second item, this is the third item. But when we talk about index, I'm going to say index here, so you can sort of visualize how that is affecting things. The first value is, of course, 0. It's not actually 1. So that's why I'm doing selection -1, is because lists start counting at 0. That may seem weird at first. It's kind of a computer science thing. It's maybe a joke or a running theme that, we start counting from 0 in lists because that's like, is the 0th position. I don't have like a strong explanation for why they chose that convention, but I think that, for humans, we always think, counting up from 1. I'm sorry about that, Aiden. let me slow right back down here. So we're basically just collecting the user input, but making sure that that input is legal. That is all we've done in this method getPlayerChoice, and it will allow us to make sure that the way we're proceeding is allowed. Yeah, I just saw a hand go up. You also need to update the values list with an X, right? So the player is playing with X's and the computer is playing with O's. So the values at selection -1, we're just going to set that up to be X, right? We're saying that now at the exact same spot on the board that used to be an empty space, like all the values are empty spaces at first, we're saying that now, okay, we're actually going to write that as an X. So yeah, I'm sorry for anybody feeling a little bit lost here. We are actually done the method here once we write break. If you would like to sort of just poke around and look at the code in a way where it's running, you can see that it's working on the bottom and everything. I again would really encourage you just to hop over and instead of using the template code here, to copy the full file and just to have that in a separate tab so that you can have a working copy on your computer and sort of getting a sense about the way each of the methods are achieving those different questions that we're asking, right? And I've named them descriptively, like this one is literally asking the computer to give a choice on, I'm gonna zoom in here, sorry. Okay, computer choice is, getting that computer input. This is actually just checking, is it a draw, right? Like, do we have any options left to choose? So each of these methods are solving an individual problem, and that's sort of just where we're at. Again, this method is done, and I am going to proceed on to the next problem we had, which was update the game board with the player input, right? So let's talk about how we're actually going to display this game board and everything like that. So at the very bottom of the file, we have this method just by itself. It just says main. What's happening here is that none of these methods are being called by themselves. Like if I didn't have this here and I ran the problem, nothing would happen. And so we're addressing that is by using something called a main method. And so when I call main, it means that all of the code will run inside of here. So yeah, let's just get started. Like when the game starts, we think, okay, we need to have a loop where it's always running until the game's over. And so when we need something that's always running, I'm just going to do a while true statement, right? While true, we're just going to run the game. The first thing we're going to do here is, get the player choice. And again, for anybody that missed the scroll, basically we finished up the get player choice method. We said all the rules that will make it so that our choice is legal. Back to the values, yeah. So, I'm actually going to get this out of here. This page here. While we're just taking a pause here, I know that there's some other people that may need clarification just about sort of what's happened here. Please do let me know, and I'll go over that. This break statement is breaking out of the while true loop. So if there's ever a selection made that's not an integer, all this will never happen. It will just say, hey, error, and it will immediately bounce from there all the way down to value error, and these things won't happen at all. It will print out, the error statement, and then we'll just take it from the top. It's a while true loop, so it's going to end and go all the way back up and just ask for the selection over again. But if it makes it through that step, it will also check for the legality of that move, like is that move inside our allowed options? Likewise, going to the assertion error when that is not found to be acceptable. Okay, I'm going to scroll back down here. Again, check out the GitHub file if you want to take a closer look at that method. So we're talking about getting the player choice for the main method here. The first thing we need to do is just display our board. So this is going to be really quite useful. We're using that method from before in the template just to print out all the values that we need. I'm glad to hear that. I hope that in the future I can deliver some content that is more acceptable for that. So that said, I am going down here. I'm going to display the board for our game using those lists that we set up from before. And this number 1 here will basically be a 1 or a 0. And it's going to tell our program whether or not we should print the choices that we can make for the user. The reason for this part is that we will say, okay, the robot doesn't need to see what the options are. The robot will just make choices based on the actual value of the list, but the user likes to see that information. So we're saying, if this is a 1, then print this out. We want to see what's possible for those options. Okay. And the second thing we're going to do is get player choice. So now we're asking the user, from our method that we built before, and then we're just going to display the board without any options so that we can see the updated board. Thanks, Bobby. I do acknowledge this is definitely probably more of an intermediate to advanced example of Python. If anything, I think it illustrates how even a game like Tic-Tac-Toe takes a lot. Whereas in Scratch, when we have our game board just set up initially, it would be a lot easier to go from the idea of the game to just having the screen right there, clicking on the options. So this game is definitely better suited for Scratch, but overall, I think this is still a good illustration of how you would be able to make a game that is printing out your game board each time you make a decision. So yeah, thanks for your patience again. This is a learning experience for me as well, and I'm far from perfect, so I never wanted to claim anything like that. I just appreciate your patience and helping me learn through the process. So we're displaying the board here without any selections, for just showing what we've done. And we want to say, okay, if that move that we just made results in a game over, then we return. Return just means that it's going to end the main method and the game is over. Something just popped up on your screen. Okay, So here we're keeping it really conceptual, right? We have this little block that is both displaying the board of our game and getting the getting our player choice, which is you. And now we need to think, okay, well, how is the computer going to play against us? Right, right. So I'm just going to write out really quick, the computer says, nice move, but now it's my turn. Okay. I'll also really quickly just write import time and random. This is a way that in Python we can import things that other people have made and that we can use. So there are tons of different libraries in Python. Like if I wanted to do something on the web, I would import web-based libraries. If I wanted to do something with math, I could import NumPy or anything like that. And this is just a way that we can import. Was it time? Sorry. Yeah, it was for sure. And then from here, we're able to use these libraries to make our computer do other things. Computers think really fast. And so I'm actually going to put the program to sleep just for 3 seconds to make it seem like the program is thinking. It's deciding on what to do. And from here, we're going to get computer choice. It's going to make its decision. It's going to look very similar to the way we did this one, but it's going to be way shorter because we don't need to do any error checking. The computer is going to make a legal choice 100% of the time, so it's going to be a lot easier to write this method in just a second. Then we're just going to display the board, values, choices, and now, again, the ones and zeros at the end are saying, should we tell or should we print out that extra piece of information? Options 1 through 9, what kind of options can we make? That's what the 0 is for. And again, if we're saying, okay, well, maybe the robot won the game, check game over, and just return true. Or just return it. Very cool. So this is actually our whole main method. You can see that we've divided it into like 2 logical pieces where we have the player making a choice in one section, and then we have the computer making a choice in the second section. And they're going to just go over and over and over in this forever loop, this while true loop, until the game over method says true. And we'll build that in just a second. So let's actually just do that right now. It's a one-liner. It just takes one line. So we're going to say this check game over is true. It's a game over if we have the win condition as true, or check if draw condition is true. Like either one of these is going to be enough to end our game. So that's just a one-liner, and we're going to build these 2 different methods, the win and draw, to decide on how that will happen. Okay. All right. Just thinking here. Let's do get computer choice. So just underneath get player choice up here, this is a big block of code. Let's talk about the computer choice and why it will be a lot easier to do. One other thing that I was meaning to come back to when I was writing this at first is that we're using variables here like options, choices, and values, but we didn't have them as parameters, right? We didn't enter them in. So I'm going to use something called the global keyword. And then write them down here so that we are able to access those pieces of information inside of our choice method, okay? And I'm just going to really quickly copy and paste this into our computer choice method as well, because we're going to need that information just the same. So I'm going to make a selection. And selection is just our word for let's get that input back from our computer in this place. And before when we imported random, this is going to be where it comes in handy. We're going to make a random.choice. So this .choice method is part of the random library that we imported. And we're going to be able to use that to make a selection from options. So instead of having all this junk saying like, oh, if you enter something wrong, oh, if this error happens, this is the computer equivalent. This is just all we got to do. It's going to make a choice that's legal all the time, which is great. And so once it does make a choice from the remaining legal moves, we're just going to remove that selection from options, right? So we're referencing this list called options, and we're removing the number that we chose. It's always nice to see people That's awesome. How do you do it on Scratch? That's a great question. I think it's a little bit outside of the scope of today's lesson, but I'm more than happy to build that and put it up on Scratch. I'm sure there are a lot of other ideas about how to do that really well. So yeah, that's pretty exciting. I would do something like when you click on the screen, making a clone in Scratch and having a sprite for X's, having a sprite for O's, something like that. But it's if you can dream it, you can build it. If you have an idea about how you think something should work, don't give up. You can absolutely figure it out. So yeah, we have basically said that the options are being removed, or that selection is being removed. And now we also want to make sure that the choices that we're displaying as being equal to a empty space, so that it will look correctly when we print it out. So we have the values also being updated to be an O. This is the big difference, right? We have up here, we have the values being updated to an X in the player choice section, but in the computer choice section, we have it updating to an O, which is pretty, it's descriptive. It shows you how it's going. I actually don't want a return statement in the choice methods because these are mostly just collecting input and then they're done after that point, because it's updating all the information we need inside the lists. So it doesn't really need to return anything. Okay, so that's cool. Basically, we also want to say, for check if draw, we're saying, are there any options left? If both players have made choices, no one's won yet, how do we tell if it's a draw? Well, we need to know about the options that are left over, right? We need to know what kind of choices can be made. And say, if the length of this options list is equal to 0, meaning there's no options left, they've all been chosen, we're going to just print out, hey, it's a draw. Return true means that when we run this method, it's going to be true if it is a draw, and it's going to be false if it's not a draw. So, oh, I'm sorry, this needs to go inside the length options. That's actually really important to have the indentation, because if we had that, it would always be true, no matter if it was a draw or not. But only when the length of the options is 0 is it true. That means it's a draw. Okay, so check if 1 is going to be kind of our big method. For the scope of this lesson, and based on other participant feedback, I think that this is a good section to copy and paste. So the best way I can describe this is actually using a pen. So I'm actually just going to draw something and then share it on my screen here. I added a few comments to this method to try and explain exactly how we're deciding if the game is won. So we have the board coordinates from before, 1, 2, 3, 4, 5, 6, and just that's sort of how we're collecting the input. The way I decided to solve this problem was by letting each of those coordinates be called a different variable so that I can access them. I can say in natural language, hey, what's on the top left side? Hey, what's on the middle right side? So I'm giving variable names to the values at each of the coordinates. And so I'm going to copy and paste that over, save a little bit of time. Again, I will point out that on that GitHub page I shared from before, there are 2 files. And in the second one is where I'm going right now, tic-tac-toe.py. And just down here, this section is adding all of those variables as the name, top left, top middle, top right, and I'm accessing the values within the list at that position. Okay, so this is a little setup step. We're just getting it all ready to go. So that's cool. And to think in terms of the board, I wrote out the number, sort of the lines, the different ways that we can win the game. Of course, across the top of the screen, when we have 1, 2, 3, we're talking about the horizontal win right there. That's one way that we can win the game. 4, 5, 6 is the middle horizontal row. And then 7, 8, 9 is the last one as well, right? So we're basically going to make all of these checks that will be basically every possible winning combination. And our code runs so fast that it will just complete that right away. And we have 8 total checks to see if we've won the game of tic-tac-toe. Now, to do this with code, we could, write it out piece by piece in terms of the same organization. But I just wanted to point out that there is another way to do this, and I thought it was a little bit more elegant than the other way. So I'm going to write out a few if statements here. So this, what I just wrote, is I'm saying, okay, if the value in the top left corner, and then this little exclamation point equals that I wrote, we say not equals. So if I have 2 equals like that, that would be, hey, that if the top left spot is equal to the space, well, in this case, we're saying, oh, is it not equal? What I mean by that is the space either an X or an O? And so if that is the case, then we want to make some checks. I also am interested in if mid is not equal to empty space, and also if bottom right is not equal to the empty space. So I'm just going to stop screen sharing just for a quick second so that I can show on my camera what I'm talking about with top left, mid, and bot right. So you should see on my camera there that I've circled the top left, which is 1, the middle, which is 5, and the bottom right, which is 9. And so that's actually what I'm doing here. And for the first check, top left, I'm just going to write out really quickly the directions we're going to check in the first step for number 1, okay? So for number 1, all those arrows I just drew, we can check by only talking about the top left spot. Like if the top left spot isn't equal, any one of those lines that I just drew could be a winning combination. So we're just going to check them all in order, okay? So I'm just going to share the screen back in just a moment, and then from there we will talk about how we're going to check each of those 3 lines in the top left section of the code. Okay, so basically, the comment here is, if 1, 2, 3, this is the top row, or we have 1, 4, 7, which is going straight down. It's the first column. And then we're saying or 159. So the way we're going to compare three values at a time is by using AND statements as well. This is going to be, we only have about 15 minutes left, and I want to make sure that we get through to the end. So again, using that side link, I'm just going to make sure that we can bring that code over. And let's just talk really quickly about how this is actually working. We'll just zoom in on this first one. Don't click any links in the chat there. Normally don't share any links. Sorry about that. If you want to describe what's going on, then that's also possible. Sorry about that. Oh, yeah. Okay, well, yeah. Whether it's Rickroll, which is kind of harmless, or other things, generally, please don't click on anything in the chat. It's just one of those things where we can't ensure the safety of any links like that, even though I can see it as YouTube. So yeah, just zooming back in here, we have the top left equal to top mid, right? So we're comparing number 1 and 2, or I'm sorry, number 1 and 5. Oh, number 1 and 2. Sorry, folks. Yeah, top left and top mid are numbers 1 and 2. So we're saying, hey, if these two values are equal to each other, and also top left is equal to top right, that means that 1 is equal to 3. We've basically confirmed that all three values are the same. And this is kind of the technique that we're going to use over and over to make sure that all the different values can't see. Okay, so hopefully it comes through in a second. I can see that my screen is being shared, but can anyone else not see my screen since I reshared it? It might take like up to a minute in the past to update that stuff. Okay, some folks can, some can't. I hope that it will update soon for you there, Ruby. And switching to the other file, in the interest of time, I'm going to bring these other checks over for each of the different parts of our problem to check. The comment on the very top, like if numbers, is referring to the coordinates for the board to show you in bracketed sections between the ors which values. And that's kind of the essence of how we're going to check if it is a one game. We're just going to manually see, are these values all the same? And if that's true, we're declaring the winner of the game with the X or O value that we're checking. So that other method is going to just print out the winner of the game and decide who to congratulate based on that information. If none of that was true, we're returning false, right? If all of these checks happened, nothing happened, then we're saying, oh, well, it's not a one game yet, is it? Perfect. So now that we have that, we are almost done. We have all the methods we need. Variables are set up, all that good stuff. We're checking if the game is won, declaring a winner for the game as well, or check if won. A little discrepancy I had, check win condition in the big file, and then check if won in the second file. Apologies there. Declare winner will be the one we're talking about next. So global values and choices. Hey, winner, like this value that we've passed in, right? We're declaring the winner for bottom right, and that value for bottom right is literally being plugged right in to this here. And so we're saying, okay, if this X or O value is equal to X, oops, and we're just going to say, hey, you win. Which is really exciting. We beat the computer. And you can also use an else statement here because it is only possible to have two options for winner. but I'm using an elif statement just to show what the other value might be. It makes it a little bit more descriptive. I'm going to say print no, robot wins. Okay. And we're also going to say, thanks for playing. And that's kind of the essence of running this section. We're also going to return true just to say, yep, a winner has been declared, and we're all good to go in that respect as well. So really quickly, I'm just going to make sure that we have check win condition, or check if one, sorry. I have to make sure that all of the uses of this are being done correctly, and make sure that there's no check win conditions. Yeah, that's good. All right, and I think the last thing to do is just to run the game and try and debug it, see how we're doing. So I'm just going to zoom out so that I can close that. And at the very top left here, we have the run button. So yeah, top left, we need to find our indentation on top left. Oh, okay, it's because I had a return statement right at the beginning of check if one, so that was a little bit confusing for my program. I'm going to try to run it again. Declare winner, we're expecting an indentation block beside that. Declare winner. Oh, I see. Top left. Expecting an indented block. Oh, okay. It's because I copy and pasted it. Some of my tab marks turned into spaces, which definitely it's good to have those kinds of conventions in place. I'm just going to make sure all these things are working correctly. Again, if you want to see the code in action, definitely check out the other page, but I'm just going to make sure that this one will run. Debugger, that's a great question. So still can't see. Oh, sorry to hear that. Debugger is a term for a program that helps you find things that are wrong with your code. So when we talk about debugging, we're talking about fixing problems with how our code is running. So when people ever say, oh, I'm squashing bugs, or I'm trying to find bugs in my computer code, that's what they're referring to, is they're trying to fix little problems they have. So right now I'm doing a little bit of debugging. I'm finding these little problems that are being told to me by the statement at the bottom, and then I'm just trying to run it to see what happens. And voila, I've debugged my program. I went through each of those things it was saying and tried to adjust those little things. Sorry for that. And yeah, so anyone that can see, we've successfully sort of rebuilt our program from, we had our target that we were aiming for, and using that template, we were able to step-by-step understand the different parts of Tic-Tac-Toe and how we can build on those ideas, making little checks for each step of the way. So of course, we can play now by choosing by number from this section. It does, however, look like one of the values is not being updated, so we can be sure to fix that as well. So for the X's, it's not updating, but for the computer, it is. Their choices are being reflected correctly. Win condition is working. It works. That's awesome news. Good job to anyone. I know that this is a bit of a clunky delivery. I definitely got to rethink the approach in terms of how I want to present these ideas and make it more accessible. So definitely taking that feedback to heart. But for anybody that did enjoy this and maybe learned a thing or two about how we go from really high level, we take game rules, and then we start to build methods. We start to make our tool belt about how we're going to solve each of those problems. That's super transferable. You can use that in other places, those ideas of how to build programs. So really quickly, I'm going to go back up to my get values as selection -1. Should be updating to x. Oh, and then I actually didn't say that it should be equal to anything. That was my problem there. So the choices here were basically every time I was making a selection with my x, it was not updating the choices by number to eliminate that choice from our board. So that was the problem I just saw. I was like, oh, why is that happening? And so I just scrolled back up to exactly in the code where mine is updating. And then I saw this empty space that was missing. So now that I've added that and I run my program, I expect it to remove these numbers that I'm choosing on each. So yeah, I'm super happy for you. Nice job, everybody. Games are a really fun way to get started with programming, just in terms of making something that just has very few rules. I think that's what's so appealing about games is that, when you can only move in a few directions, you can only make a few kinds of decisions. As the programmer, you're like, awesome, there's only a few things that can happen. Now I can make methods to address each of those possibilities. Great job. That's awesome. So I'm going to try and play a really bad game really quick, and hopefully the computer will beat me. Again, we made a random agent. Yeah, so basically, and feel free to, remove any comments, like all these, hashtag writings and stuff. You're more than welcome to share this project and pass it along. It's like show people what you did today. Two-player version. So that's a great question. Basically, if you wanted to make this two-player, you could use the internet, or you could do, just side by side playing against maybe your parent or whomever. All you would do there is instead of get computer choice, you would rename this like get player two choice. So your player choice would be like player one choice. And then for player two, you would be able to have pretty much the same code, except that this would be a O instead of an X. You might be thinking, well, I don't want to have two blocks of almost the same code. That seems really, the word for it is redundant. You don't need to copy it. The way you would get around that is you would say, you would add a parameter or an input value on your method to help your program know which player is playing. So it would be like 1 for player 1 or 2 for player 2. That would be a little input on get player choice, so that down in your main method, instead of saying get player choice, get computer choice, you would get player choice twice in a row, but then you'd also pass that value of, hey, is it player 1 or is it player 2? And then update the board based on that with an X or a O. And again, to share this code, you can also see this download link on the far right side if you've explored the interface a little bit. And if it says changes you made may not be saved, and that makes you nervous, you can always just select everything and copy it, Control C, before you download the code. This is safe to click leave. It will just do a pop-up on your computer to save the Python file. So yeah, that's kind of the gist today. I still want to get the computer to beat me if possible. I want to choose number 9. Weird moves. Are there any other questions, folks? I know it's been a lot today. Thank you so much again for your patience with the whole process. I hope it was enjoyable for you. I hope you learned something, or maybe got more now know more about Python, and maybe you'll consider using it to automate something or anything like that. So robot won this one. Randomly chose 3 down the first column. Thank you so much. Really, it was super fun. I, again, will take feedback to heart and make sure that, next time around we have a better runway for getting into these things. So yeah, thanks for your patience. And, I hope it's been a great week. I hope that, school is awesome when it does get picked up again in this semester term. I know it's been super unpredictable. So, sincerely thank you for welcoming me into your daily routine today. And yeah, definitely use GDB anytime you want to mock up some Python code, and you can always download it there. There's lots of awesome tutorials, really talented people who can say it better than I can, and they'll show a lot more cool features that you may want to use in your own life. So thank you again. Download the game. Yeah, so far it is the download code button. I'm hovering above that on the far right side here. If you can see that, then I'm going to left click. It will have a pop-up that says for me, leave site. I click on leave, and it just is a pop-up window on my computer for save as, and it will show me, my files, and I can save it as a Python file. However, if you wanted to download it from GitHub, you can also just do it that way as well. So again, thank you so much, and hope you have a great day, everybody. Peace.